So as I promised, this is a video for an example of average shear stress. So this is the second video of a two-part series. So in this example we have a knuckle joint which is connected by a bolt here, and that goes through each of these tines of the knuckle joint. So we have to find, given that the allowable shear stress is 40 megapascals, we have to find the minimum diameter of the bolt, D, so that it satisfies the allowable shear stress 40 megapascals. So it cannot exceed that 40 megapascals. So in order to start this problem, I have to figure out what the forces that are going through each of these tines. So when I look at this right knuckle here, right part of the knuckle joint, the forces that go through each of these three tines are going to be the same. So I really just have to analyze one of the three. And similarly, when I analyze this left-hand joint, the left-hand portion of the knuckle joint, the force that's going to go through this tine and this tine are going to be the same. So I just have to analyze one of the two. And basically, the internal force that's going through those left and right sides is going to be different. So one is going to be a limiting case, meaning one is going to be more critical than the other one. So let's start off by looking at this left-hand side. So if I just redraw this picture and I look at this left-hand side, we're going to have something like this. So if this is 70 kilonewtons, it has to balance by 70 kilonewtons on the other side, which this is going to be half of that, so 35 kilonewtons. This is going to be 35 kilonewtons. And the bolt goes through here. So it's going through here. So there's four areas of contact here that's going to shear. Again, the force is going parallel to this surface. It's going parallel to that surface, so it's shear area. And I just want to analyze just this one tine. So if I further break this down, we have this one. We have 35 kilonewtons. So that means there's going to be 35 kilonewtons over here. And again, the bolt comes through, and the area, the shear area in question, is in contact at the top and at the bottom. So we effectively have two areas that we need to consider. So again, the equation for average shear stress is going to be P over A, and I'll say area shear, or area contact. And this average shear stress is basically limited to 40 megapascals. So this is limited to 40 megapascals. We know our P is 35 kilonewtons because that's what's going through, that's the internal force that's going through this part of the member. And the shear area is basically twice the cross-sectional area of the bolt. So if we write all of that in, we have 35 kilonewtons divided by area is going to be, again, twice the area, twice times pi over 4 times d squared. That's area of a circle, and that equals 40 megapascals. So basically I just want to isolate d. So I isolate d, and that's going to give me, let's see, 35 kilonewtons divided by 2 times pi over 4 times 40 megapascals. And I'm writing the units in here because I want to be consistent with how I simplify my values based on my units. So I'm going to make everything common units. So 35 kilonewtons is the same thing as 35,000 newtons. I'll cancel this 2 out, so that'll be pi over 2 times a megapascal is times 10 to the 6 pascals, which again, a pascal is a newton per meter squared, and 1 megapascal equals 10 to the 6 pascals. So this is going to be 10 to the 6 newtons per meter squared. These newtons are going to cancel out, and when I take the square root of this meter squared unit is going to turn into a meter. And when I punch all of this into a calculator, I should get 0.0236 meters. If I change this to millimeters, you multiply by 1,000, so that'll be 23.6 millimeters. So that's my diameter for this left-hand side. So I'll call that case 1. So for case 1, my minimum diameter is 23.6 millimeters. Okay, so what happens if we analyze the right-hand side of the knuckle joint? So I'll just draw the right-hand side. We have a load 70 kilonewtons going to the left. So that means in each of these sections, this should be, these 3 sections should add up to 70. So basically it'll be 70 divided by 3, which equals 23.33 kilonewtons for each of these. And the bolt goes through this whole thing. So when we're looking at this, it's going to shear there, it's going to shear there, 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 there. And I just want to look at just this one because this is the average shear stress. We can just look at one of the members. So shear average, again, which is limited to our shear allowable, which was given as 40 megapascals, is going to be P over A. And when we just look at this part of the knuckle, we have 23.33 kilonewtons going left, so it's got to balance out by 23.33 kilonewtons going to the right. And the bolt is just coming through here, so that the area shear is going to be, again, twice the cross-sectional area of the bolt. So again, this is another example of double shear. For both of this is double shear, it's shearing in 2 places. So this 40 megapascals is going to equal, P is going to be 23.33 kilonewtons, and it's going to be divided by the area, the shear area, which is 2 times the cross-sectional area, pi over 4 times d squared. So again, if I isolate d, the square root, it'll be 23.33 kilonewtons. Oh, this is kilonewtons, that's bad. Divided by, I'll cancel this 2 and this 4, so it'll be pi over 2 times 40 megapascals. And again, like in the last example, I'm going to get common units, so this will be 23,330 newtons rather, divided by pi over 2 times 40 times 10 to the 6 pascals, or newtons per meter squared. Again, the newtons cancel out, and this meter squared units comes to the numerator, and we take the square root of it, it'll turn into meters. And when we simplify all of these numbers, we should get 0.01927 meters, which is equal to 19.27 millimeters. So this is our diameter for case 2. The case 2 is, we'll call this one case 2, when we're analyzing the right hand side. Okay, so we have, when we analyze the knuckle on the left hand side, we had 23.6 millimeters as our minimum diameter. When we analyzed the knuckle on the right hand side, we had 19.27 millimeters. So which is the minimum diameter that we use? And I know this can get a little confusing, but if you just reason through it, it really makes sense. Well, let's say we made 19.27 our diameter of the bolt. Well, for case 1, it says our minimum diameter has to be 23.6. Well, 19.27 is less than 23.26, so it's not big enough to handle the shear stress. So we can't use this. The minimum that we can use is going to be this 23.6 millimeter diameter. So that is the what we call limiting factor, and our minimum diameter will be 23.6 millimeters for the bolt.